Hello! Welcome to a video called Interacting Objects. Now, what does that mean? Well, in object-oriented programming, it's very likely that we're going to have multiple classes that specify or define different kinds of objects, and that we're going to have instances of those objects in our program. And one of the things that we very often want to do is that we want one kind of thing to be able to interact with another kind of thing, okay? And that is a classic kind of, question that we might have is how do we write the code that allows one kind of object to interact with another kind of object, given that, as we've seen, a class, which is what we use to define objects, always only kind of talks about one object, right? The flower class only talks about flowers. So if I want something else to interact with a flower, like a bee, for example, that's the example we'll use, how do I go about that? So that's what I want to cover in this video called Interacting Objects. Let's begin. And let's begin with our garden code again. So this is what we've been kind of accumulating over time. I've removed the code that helped me to grow flowers by clicking on them. So we're back to just a simple garden that looks like this, right? Some varied flowers appear on the canvas, and that's that. So let's motivate a need for interaction. And let's do that by having the flowers die, because that's what I thought of when I was thinking of this. So what I would like is that, let's go look at our garden again. Over time, these flowers should shrink. And what I'll do is I'll just have the kind of head of the flower shrink. And if it shrinks all the way down to 0, then the flower is going to die. It's going to disappear. So how do I go about that? Well, there's a few things that I'll have to do. One of the things I'll have to do is I need a new property, because I've got this idea of whether a flower is alive or not. I'm going to need to have a property that maintains that information. So whenever a flower is created in the constructor, I'm going to have another property called this.alive. So the alive property, and it's going to start out as true because the flower is going to start out alive. And then the other thing that I'm going to need in this flower is I need some way to make it slowly die. I'm sorry, this is just the way that it's going. I'm going to define a method called shrink, and this method is going to be called every frame, and each time it gets called is going to shrink my flower a little bit, and it's going to check if the flower shrinks so small that it's like basically disappearing, then it's going to die, and I'm going to set the alive property to false. So let's go about that. So I'm going to declare a variable called shrinkage. This is how much it's going to shrink when this method is called each time. And I'm going to do it randomly just because, I don't know, that seems a little bit more organic. And I'm going to set it to a number between 0 and 0.1. So a little bit. I don't want it to like vanish super fast. So this is a very small range that I'm defining here, because I want to just take a little bit off every frame. And with that shrinkage number here, I am going to want to reduce the central element of my flowers. So that is called this.size. So I'm going to make that smaller by the shrinkage amount. So I'm going to subtract shrinkage from it. So that'll make the center of the flower get a bit smaller. And I'm going to do the same thing to the petal thickness as well, so that the petals kind of wither away in this depressing experience that we're creating. And rather than subtracting shrinkage from this, I'm going to divide shrinkage by 10. And the reason I'm doing that is just that the petal thickness is a much smaller number than the size is, right? And I don't want the petals to shrink away as fast as the main body of the flower. I want them to shrink a little bit slower. So I'm dividing by 10. This is kind of hacky. And again, if I were writing this program better, I would come up with a better solution than this, including not just using the number 10 here. Okay, so these 3 lines of code make my flower shrink, right? They reduce the size and the petal thickness properties. I then want to check, well, did this kill the flower? So what does killing the flower mean? I'm going to say that if the petal thickness or the size get to 0 or less than 0, then it's dead. So I need an if statement, and I'm going to say if the size of the flower, which is the size of the central element, is less than or equal to 0, it would be dead. Or, and I'm going to use those 2 nice pipe characters there, or if the petal thickness of the flower, which is also being shrunken in this method, is less than or equal to 0, then it would also be dead. How do I tell it to be dead? I set this.alive to be false. I don't need a dead property as well. the opposite of alive is dead, unless you want to get super metaphysical about it. So that's my shrink function. Chooses a random amount, shrinks the center of the flower by that amount, shrinks the petal thickness by a related amount, and then it checks if either of those two properties have gone below zero, at or below zero, and if so, the flower dies. So it remains to incorporate this new method into my main script, right? So that the flowers actually do this. Where do I do that? In draw, right? Because it's happening every frame. So in here, I get a flower from the garden with this first line here on line 47. And before I display it, I'm going to tell it to shrink. So I want to call its shrink method. So I say flower dot to access one of its methods, and then shrink is the method I want to be calling. And that will shrink it, right? So it will shrink and then it will display. But there's one other thing that I probably want to do. Now that a flower can be alive or dead, I don't really want to shrink and display flowers that are dead, because it doesn't really make sense. So rather than always call shrink and display on every flower in the garden, I'm going to first check, is the flower that I just pulled out of the array that is in the flower variable, is its alive property true? And if it's alive, then I will do these two things. It will shrink and it will display. If it's not alive, then I don't really need to do those things. So it's just kind of a waste of time. So there I have added in this idea of shrinking and also caring about whether the flower is alive. So let's go look at our garden. Hopefully that works. Oh, it's pretty sad to watch. So you can see all of the flowers are slowly shrinking, and when they eventually dwindle all the way down, the flowers disappear. This is not really what it looks like when a flower dies, and if we wanted to be more sophisticated, we might change colors and all of those sorts of things. But it's a decent simulation of dying flowers, right? Now all the flowers are dead, and it's very sad, and that is life. But if only it could be different, right? So we've now created a problem, I guess, in the simulation. The simulation is now kind of more accurate in the sense that something happens, time passes, and the flowers change, they die. But now they all just die, and that's that. So now what I want is I want to add something, a new kind of object that can interact with the flowers once I get it started, and it can help the flowers survive. And I'm going to make a bee to do that. So what I want is some cute little bees that are going to fly around in the garden, and when they touch the flowers, the flower will get bigger. And actually, to make this kind of like a proper ecosystem sort of idea, the bees will also be shrinking. So they also need to go onto the flowers to whatever, collect nectar. So they get bigger so that they stop shrinking. And the flowers shrink unless there is a bee pollinating them, right? And that is not how pollination works. Clearly, this is a terrible kind of representation of the actual ecology of this whole thing, and the biology of this whole thing, but it's good enough for this simulation. So I want to add a class that defines a bee. So this will be my second class, right? The bee will fly around randomly, and when it touches flowers, it's going to pollinate them. And that's going to be good for both the bee and the flower. So quite a lot to do here, and rather than just type this whole bee class out, I'm going to paste in code and review it with you. But the first thing that I always do when I create a new class is I need to create a new file. So I'm going to do that now. So again, I am going to create it inside the JS folder. So I'm going to right-click and create a new file in that folder. And because it's bees that I'm creating, I'm going to call the file bee.js, capital B. Now I have my file ready. I'm now going to paste in a bee class so that you don't have to watch me typing. I know you like to watch me typing, and it is kind of ASMR styles with the sound of clicking keys perhaps, but let's not go there right now. There is a bee class. I just pasted it in from the notes for this particular module or topic. So how does it work? Well, again, same kind of idea as the flower class. We write the word class, then we write the name of the class. It always starts with a capital letter, so the bee class that defines what a bee is starts with the letter B, capitalized. Importantly as well, just by the way, I know that sometimes it might feel like you want to call it bees because you were going to create lots of bees out of this class, that you might want to pluralize the class name, but you shouldn't do that because the class just defines how a single bee behaves, right? So the class defines a bee, it doesn't define multiple bees. We create multiple bees out of the class. Just a small distinction to think about. So what is a bee like? Well, in the constructor, we can see it gets a couple of parameters, x and y, that determine its position. So we set this.x and this.y. It has a size. It's going to be just like a cute little circle with eyes. We don't need to worry too much about its appearance. It's got a minimum size. I didn't do this with the flower. I'm realizing it's okay. I just checked if the flower dwindled away to 0. For the bees, if they get down to 10 pixels in size, if they get smaller than that, then they're going to be dead. Dead. And because the bees move, they're going to have velocity, Vx and Vy. They're going to start off not moving. For the same reason, they're going to have a speed. That's how fast they can move in any one direction. And because the bees get smaller, and again, I didn't do this with the flower, I just made the flower shrink by a hard-coded value, but the bee is a slightly better written class. They're going to shrink at 0.05 pixels per frame. This jitteriness property is going to control how likely it is that a bee changes direction while it flies around. So this is some classic kind of just movement control, is that it will change direction 10% of the time. So it sort of acts like a bee. And just like flowers, the bee can be alive or dead, and bees start out as alive, so that's true. So that's our properties that we're working with a bee. And then the key things that a bee can do, like a flower, bees are going to shrink over time. That's to represent that they're dying. It's sort of a visual metaphor, right? Bees don't really shrink that much when they fly around and eventually die. And we'll do it by just reducing the size of the bee by its shrink rate, and checking if that size goes below the minimum size. If it gets down below 10 pixels in diameter in this instance, the minimum size, then we set alive to false, and the bee is considered dead. Alive is false. It's falsely alive. It's not actually. That's a terrible way of saying it. Alive is false. Let's just stay with that. Bees can move, so we've got a move method here as well. Again, you can see the correspondence as to how I've been writing this kind of code in a sort of more straightforward function version of this kind of a program. It's just translating those exact same ideas into the context of a class, which really just means things like the move method here doesn't have function in front of it, and all of the properties of the object that I'm using, we use this dot in front of them. And apart from that, it's conceptually exactly the same. So a bee moves by generating a random number between 0 and 1, checks if that random number is less than its jitteriness factor, so we know that 10% of the time the random number will be less than 0.1, and so it will make this decision here 10% of the time. And it does its standard thing. It sets its x and y velocity to a random number between negative speed, so it can move left or up, and positive speed, so it can move right or down. Then we update its position based on that velocity. And finally, just to keep things relatively simple and under control, the bees can't leave the canvas, so they're constrained to the canvas. As I say here, it's like a walled garden. Ha ha ha. And that's how they move. And then finally, displaying a bee. I'm not going to review this. Bees are just, it's sort of meant to look a bit cute. So they've got wings and a body and a couple of cute little eyes. Well, we'll see what they look like in a second. Okay, so that's our bee class. That defines what a bee is like. But the class on its own doesn't do anything. And it really doesn't do anything because I almost forgot the one other thing that you always do when you add a new JavaScript file to your project, which is that you go to index.html and you make sure that you add a new script tag. So I copied and pasted the flower one, and I'm changing it so that it includes the bee.js file. If I hadn't done that, anything I did with bees in my main script wouldn't work. So that's always a classic problem to look out for. That was silly of me. Okay, so I've got my bee class. I've included it in my index.html, but it still won't do anything in the sense that this just defines a bee. If I want to use a bee, I have to actually create bees and use them in my main script. And I'm going to do basically the same thing that I do for my flowers, right? I'm going to have an array of bees. It's going to be called bees because that's a good name for it, and it's going to start out empty, so empty square brackets for my empty array. I'm also going to have, I shouldn't really have put that in between flowers and the number of flowers. I'll do it there. How many bees in the garden? I'm going to need a num bees thing, right? Num bees. How many bees should there be? How many bees are there in a garden? Let's say there's 7 bees and see what that does. 7 bees is how many bees I want for now. And then I'm going to need to do the same kind of thing that I did for my flowers. Create the bees. Send in the bees, and we're gonna do that by doing the same kind of for loop. I is less than garden.numBees, because we're going to create that many bees, I++. And I'm going to say let b, because I'm going to create a new b and put it in here. I'm going to say new, like I always do when I want to create an object out of a class. the name of the class is what we use to call the constructor, so new b. And its parameters here are an x and a y. Again, I'm just going to use random numbers. I'm just going to type them straight in here. I could have done the same thing that I did with flowers, where I created sort of temporary variables to make my program a little clearer, but I'm trying to work a little faster here. So we create the new b, and then in the bees array, garden.bees, which is the array, I say push by calling its push method, and we push the bee that we just created. So this will add 7 bees into the bees array of my garden. So that creates the bees. Same basic idea as the flowers, right? This is a sort of a template. One thing, I will just quickly point out, notice that I can use I, so I've got let I here for the first for loop, and then I'm also using let I for the second for loop. I'm allowed to do that because these i's, they only exist inside this block of code here, okay? So this I, after this block of code, after the for loop finishes, then I just kind of vanishes and I can create a new variable that is also called I. So I don't have to keep coming up with new letters in this instance. And we'll look at a slightly different example of this kind of variable just a little later on. So I've created all of my bees. Now I need to do, again, same kind of thing that I was doing with my flowers, which is I need to say for. Again, I can use I is less than garden.bees.length. Now we want to use the length property of our array because we might be adding and subtracting bees potentially. In fact, we're not, but we could. And for every single one, I want to grab the b at the garden.bees at that position, that index. And again, bees can die, so if b.alive, then b.shrink, shirking. Bees shirking could be really interesting too, but I don't have that yet. What's the next thing? Move is another method that it needs, and b.display, or it's going to be an invisible bee, which could be interesting too. So bees shrink, then they move, and then they display on the canvas. And what does this look like? Cute as hell bees flying around and dying because there's nothing for them to do. They just die. You saw they hit 10 pixels there and they all died. That's what happens to bees in this world. And then the flowers last for a little bit longer. They've just got a little bit more moxie, but then also all of the flowers die. So it's a very depressing simulation that we have created here. Okay? So it's a tragedy. Tragedy of the commons or something. But those bees are pretty cute while they're alive. We would like the bees to stay alive, and we would like the bees to interact with the flowers, right? That's the kind of the big thing that we've been building up to here, is we've got these two classes. We've got flowers and we've got bees. But our program would be much, much more interesting and a better simulation, if you like, if the bees and the flowers could kind of interact with one another. And what I want to do is introduce the idea of this kind of fake version of pollination. So what I want is that if a bee overlaps the head of a flower, which you can see they constantly do as they move around, then the bee should get bigger so that it's like dying a bit less, it's getting nectar, and the flower should get a bit bigger too. It's being pollinated for some reason, that makes it get bigger, and so they can kind of rely on each other. The bees can help both themselves and the flowers. So how are we going to do this? Well, the first question really is, first of all, what do we need to do? Well, we know that the kind of code that we're going to need is that we need to be able to check if a bee overlaps a flower, and if a bee does overlap a flower, we need to make the bee get bigger and we need to make the flower get bigger. That's the basic question. That's the basic idea, right? That's what we need to do. So if that's the kind of code we need, where should that code go, right? Should the code be in the main script, checking for overlaps in the main script, and then changing the bee and the flower from there? Or should the bee know how to do this pollination thing? Or should the flower know how to do the pollination thing? Like, where should that code go? And all of those options may have their merits. And there isn't like a really, really wrong answer to this unless it's super confusing or doesn't work. But I'm going to say that I want the bee to take care of this pollination idea. The bee is kind of the active agent here. It's the one that does the pollinating. It's the one moving around and kind of acting on the flowers. So I want the bee to have a method in which it tries to pollinate flowers. Okay? So the bee is going to take care of this. Because the bee is going to take care of this, I'm going to edit my bee class, and I'm going to add a new method to it. Okay? The new method is going to be called try to pollinate. Try to pollinate. Because it might not succeed, right? I don't want to call it pollinate because that makes it sound like it always works. It's going to be called try to pollinate, and because we're a bee right now, we won't know what we're trying to pollinate unless we have a parameter. So whenever we ask a bee, try to pollinate something, we need to tell it what it's trying to pollinate, and that would be a flower. So we're going to need a flower parameter here. And now we're free to kind of implement that code that we basically understand. What do we need to do? Well, we need to calculate the distance, as always, between the bee. So dist, the bee, so the bee is this, right? So it's this dot x and this dot y. That's the position of this bee. And the distance between that and the flower would be between that and flower dot x and flower dot y. Now, we need to check if that distance is small enough for the bee to be said to overlap the flower, in which case we're going to say pollination works. So if the distance is less than this dot size over 2, which is the bee's bit, plus the flower dot size over 2, which is the center of the flower, plus the flower dot petal thickness, which is the outside of the flower. If all of that works out, if the distance is less than those, then we would know that the bee overlaps with the flower. So what should happen? Well, we could write the code here to make the bee get bigger, but it's much nicer, I think, if we write the code for the bee getting bigger in a separate method, right? Because try to pollinate is just about the attempt. The actual thing of the bee growing should be done somewhere else. So we're going to have a grow method, which is kind of the opposite of the shrink method, right? So we're going to say this dot size equals this dot size, and we'll just use we'll need a new property. So plus what? Let's say that we've got a property called grow rate. Grow rate. So the size is going to get bigger by this property, but for that to work, I need that property to exist over here. So let's add a grow rate. This dot grow rate, and we'll just make it the same. I don't know. Let's make it the same as the shrink rate. This is something that will change how the simulation works, but let's just try that out. So the grow rate is a new property on the bee. I do that by assigning a value to it in the constructor. So size gets bigger by the grow rate. I probably also don't want bees to get arbitrarily huge. So I also up here, I'm gonna, as well as a minimum size, I'm gonna have a maximum size. It's gonna be called max size, and I'll just set it to be the same size that a bee is when it is first introduced, which is 40 pixels. So maximum size is 40 pixels, minimum size is 10 pixels, and that means that I can now go back to my grow function and I can constrain the size. So this dot size is assigned constrain this dot size, because that's what I want to constrain. I don't want the size to get smaller than the minimum size, so this dot minimum size. When it's growing, obviously it can get smaller than the minimum size if it's shrinking. And I don't want it to get bigger than the maximum size. So it's going to stay within those boundaries when it's growing. So that allows my bee to grow. So where do I call this method? I want to call it here, right? If we're inside this if statement of try to pollinate, it means that pollination worked. The bee is overlapping a flower. So how do I call this method? You might think that I would just write grow, right? That kind of would seem to make sense because it's right there and it's called grow. But because we're in a class, we actually need to write this dot grow. So we're saying call the grow method of this bee specific grow method. Otherwise, JavaScript is not going to know which bee's grow method to call, and it won't work. So we say this dot grow to make the bee grow. And we kind of want to do the same thing with the flower, right? We want to tell the flower that it got pollinated. One thing that we could do, again, here is we could like change the flower's size directly here via its size property, right? But that's considered bad practice. Instead, what we should do is we should have a method on the flower that handles whatever happens when it gets pollinated. And we're going to call that pollinate. So whenever the pollination works, there's going to be a method on our flower called pollinate, and the flower will decide what it does. It could change color, it could turn into a rocket ship and fly away, or in our case, it could just grow a little bit. So that's the other part of pollination. The bee grows by calling its own grow method, this dot grow, and the flower is going to do whatever the flower does when it gets pollinated because the bee will call its pollinate method. It's the bee's way of telling the flower what's going on. So let's add that pollinate method. It probably makes sense to add it just after the shrink method. It's kind of like it'll be the opposite of that in some ways. So we're going to define a new method in our flower class, right? We're in the flower class up here. This is flower. And we are going to do the pollination thing. So what will that look like? Well, we're probably going to want another, if we start thinking about this, right? The flower's going to get bigger. We're probably going to want a bigger size again, right? So we are going to want to, well, probably we're going to be growing the center of the flower and the petals of the flower, because those are the same things that shrink. So I'm going to need, a maximum petal thickness. Again, I'm going to set that to the default that it is when a flower is born, so it doesn't get any bigger than that. And I'm going to want a maximum size, so maximum size. And again, I'll just set that to the size that was set at the beginning when a flower was constructed. So it can't get any bigger than its initial size. We could change that, it's completely fine, but I'm just going to limit it that way. So now we can deal with pollination. We know that we want the size. Oh, can we? No, we still need more, right? We need... oh no, well, let's do this in the same kind of way that the flower shrinks. So we'll generate a random growth amount. It's going to be a random number between 0 and 0.5. Again, the decisions we make here affect how the simulation works. We're going to add that growth amount to the size, so it gets bigger. The center of the flower gets bigger. We're going to do the same thing with the petal thickness. Going to add the growth to that. But again, we'll divide it by 10 because we don't want the petals to get too big too fast. Because again, the petals are much narrower. They're the smaller kind of number than the size number. And then we also want to do constraining because we don't want the flower, again, to get arbitrarily large, unless you do, but I don't want that. So I'm also going to say that this dot size is going to be constrained. So constrain this dot size to be between whatever, 0 and this dot max size, which is the maximum size. And then same thing for the petal thickness. I'm going to constrain it. So constrain this dot petal thickness to be between 0 and this dot max petal thickness, right? So now they're not going to get smaller than 0, obviously, because they're growing, so then they're not getting any smaller. But they're not going to exceed the maximum size, and they're not going to exceed the maximum petal thickness. And this is just to stop weird, like runaway giant flowers, although again, you might be interested in that. So now a flower has a pollinate method. Back over here in B, try to pollinate is now going to do its job, right? It calculates the distance between the bee and the flower, checks if they overlap each other, and if so, the bee calls its own grow method, which makes the bee get bigger, and it calls the flower's pollinate method, which we know makes the flower get bigger. But the nice thing here, right, is that the bee doesn't need to know how the flower reacts to pollination. That's all handled by the flower. That's the huge advantage of calling a method here rather than directly kind of tinkering with the flower's properties, okay? It's a big advantage. It's an important distinction. Okay. So we're almost there, except that try to pollinate, our beautiful pollination method, doesn't yet get called. So now we need to think about how we're going to call that method in our main script. And this is I don't know, I think it's a really nice moment. So here's the thing. In order to call this method, we know that it's going to be bees that do this, right? So we know that we're going to want to do something down here. Living bees, I should say. So living bees are the things that are going to try to pollinate flowers. And in fact, they're only going to try and pollinate living flowers because anything else would be kind of silly. So how are we going to do that? Because we know that this bee, for example, so we're inside a for loop. So this bee variable here refers to each bee in the bees array. But we want this bee to try to check if it's going to pollinate any of the flowers in the garden. So we kind of want this bee to look at or to interact with every flower in the garden, and that way it will pollinate any of the flowers that it's currently overlapping. To do that, we have to check every flower. So how are we going to check every flower? We need to use another for loop. So this is a moment where we're going to be using a for loop inside a for loop, right? Which can be like a little bit, I don't know, stressful or like, whoa, you can do that kind of thing. Yes, you can do that. This is called nested for loops. Whenever we put one structure inside another structure of the same type, we call it nesting. So you can put an if statement inside another if statement. That's nested if statements. A for loop inside another for loop is nested for loops. So we want a second for loop that's going to run through every single flower because we want our bee to try to pollinate them all. Now, here's the key difference from what I was discussing earlier. We cannot use the I as the variable name for our counter here because we're already using I up there and we're inside that for loop. So this is a case where we do have to use J or something, a different variable name. I'm using J here because that's the convention. It's the letter after J, letter after I, as you might be aware. And so this loop is going to count through all of the flowers in the flower array. So we're going to count up to garden.flowers.length, j++, so exactly the same, right? We're just giving it a different name so it doesn't conflict with the I. And what are we going to do in here? Well, let's get the flower at that position first. So garden.flowers at position j, right? Because the j is the one associated with going through all of the flowers. The I was the one that was associated with going through all of the bees. So we're going to get the flower, and then what do? We want the bee to try and pollinate the flower. So we say bee, because that's the thing that has the method, and the bee is the bee that we're currently looking at in this outer loop that's going through all of the bees. And we're going to say try to pollinate, that's the method name, and we know that that method wants a flower. So which flower? The current flower that we're looking at, which is in the flower variable. So bee, try to pollinate flower. That's what we needed to do. So this outer loop counts through every bee, so it's like B0, B1, B2, B3, B4, B5, B6, because there's 7 bees. So for every single one of those, it grabs the bee. If the bee is alive, it shrinks, moves, displays, but then that bee also looks at every single flower in the garden by going through the flowers array and tries to pollinate it. So B0 first looks at flower 0, then flower 1, flower 2, flower 3, up to the number of flowers. Then we go back, and then B1 does all of its stuff, and then it also looks at flower 0, flower 1, flower 2, etc. So we loop through all of the flowers and try to pollinate them. As I was saying that, I realized one last thing, which is that we didn't want our bee to try and pollinate dead flowers, so we should add the same kind of if statement here, right? If flower.alive, if the flower is currently alive, then we want to try and pollinate it. Otherwise, we should ignore it because it's a dead flower. Can't pollinate dead flowers. And that's it. That is the structure that we need. And again, like here we're talking about, bees and flowers, right, in our loops here. But this is the basic structure that we can use to check whether one collection of objects in an array can do something with another collection of objects in an array. The structure is useful in all kinds of situations, these nested for loops. So let's go and look at that now. Reload it. So the bees fly around, and you can, I don't know how obvious it is, yeah, you can kind of see these flowers getting pollinated by the bees. So if a bee is near a flower, overlapping a flower, the flower gets bigger. And if the bees are distant from the flowers, so the flowers in the top left corner here are kind of screwed right now, because the bees aren't going over there, then those flowers die. And you can see that the overall trend of this particular simulation is that the bees and flowers are dying. Now all the bees are dead. Because all of the bees are dead, all of the flowers are now going to die too, because there's nobody to help them. But it did last for longer, right? Because everybody wasn't just constantly dying. They were helping each other out for a little while there. And this is now an ecosystem, right? This is like the bees and the flowers have this relationship. And now it really matters. All of the properties that are part of our main program, and the nature of bees and the nature of flowers, how bees move, how big bees are, how fast they are, how much a flower responds to a bee when it tries to pollinate it. All of these things affect how this simulation kind of turns out, right? Because we have an ecosystem, and all of the different factors in the ecosystem are going to contribute to the way that that ecosystem plays out. It's super exciting, right? Like we now have, like it's still a fairly simple ecosystem, but there's a lot of potential complexity. Maybe the most obvious thing that we could do is just have more bees. Like if we had 30 bees and 30 flowers, I mean, it's a lot of bees, obviously, but like now it's making life a bit easier for everybody, at least easier for the flowers, because there's always going to, there's more likely to be a bee around that's going to help out that flower. So this is probably an improvement to the life of the flowers, not necessarily to the life of the bees, because they can still kind of get isolated in a no-flower zone and die, as you can see is happening. And again, once all of the bees die, then all of the flowers die as well. Probably if we really wanted to make this a sustainable ecosystem, we'd need to do things like make the bees be attracted to the flowers, for example. That would help a lot, because then the bees wouldn't be just moving around randomly, which tends, that trends towards the bees dying because they just don't act smart enough. But that's, those are ideas for projects and for other discussions. The main thing that we wanted here is like this relationship between bees and flowers, and that allows us to have the beginnings of a much, much more sophisticated simulation that I personally think is super exciting. So what's the outcome here? It's often the case that we want two different kinds of objects to interact with or communicate with one another such as bees and flowers, like a bee might want to pollinate a flower. And the most important rule that I talked about a bit there is we should do this through methods, right? So we have the try to pollinate method. That's the thing that kind of actively handles that situation. But within that method, we have a method for the bee that handles its response, and we have a different method for the flower that handles its response. And that way the bee doesn't need to know how a flower responds to being pollinated. In actual fact, if you want to get really serious, in a lot of programming philosophies, even this is a bad thing. You shouldn't really be trying to directly access the properties of a different object from another class, or just even from your own class. So we shouldn't really be directly looking at the flower's X and Y properties according to some philosophies. Instead, there should be methods, again, to handle these kinds of things as well. That gets pretty tedious, so I'm not enforcing that, and I don't really do that in my own programming. But just be aware that that's kind of an idea that's floating out there in the world of object-oriented programming. The other big thing that we saw, right, was this idea of having two different arrays of different kinds of objects and making them interact with this kind of nested for loop structure where we go through the array that's kind of more active, so the bees, and for every bee we then also loop through all of the flowers with a second for loop. And that's a big idea and a great idea to kind of adapt to. And that kind of ends this idea of having different objects from different classes interact with one another. Powerful idea in programming and really quite exciting, I think. So thanks for listening, and I will see you in the next video.